Today's lesson is on looking at the graph of a transformed parent function and writing the equation from it. Now we've looked at what transformations are, and when you look at an equation, you're able to tell is it being moved to the left or to the right, depending on different values in the equation. But now we're going in the reverse direction. We're actually looking at the graph. We are going to identify what the parent function is and then identify what movements have been made. Now on the file in your Google Classroom, I kind of narrowed it down to just 6 graphs that I'm actually going to look at right here. So you're not going to see all this on your file. You're actually going to just see this. I was able to cut that out. So we're going to look at this first one. And what you want to do is first of all start off with what the parent function is. So this is why you need to be able to tell from the other lesson the other day what the parent functions are. So remember, anything that's a V shape is an absolute value. So I know that this is going to be f of x is equal to the absolute value of x. But obviously it's been moved. It's no longer sitting at 0, 0. And for this particular assignment, you don't have to worry about a vertical shrink or stretch or a compression. Really the only thing that's been done is that these have been moved left and right or up and down. So that's really what we're looking at here. When we look at the vertex of this absolute value graph, it's normally at 0, 0. It's been moved up 3. So because it's been moved up 3, there's going to be a plus 3 behind the absolute value. Remember that up and down is what we look at in terms of K. So I'm going to go ahead and write this just so I can refer back to it. So in this case, there is no H. The graph is staying in the middle. It's not moving left or right, but it is moving up. And the directions told us that there is no stretch or compression. So we don't have a value of A to write down, and we only have the value of K because the graph has moved up 3. So that would be the first equation for that first graph. Now let's look at the second graph right here. The second one, this is a parabola, so I know that it's a quadratic. And so I'm going to put f of x equals x to the second power. However, it has been moved. Again, it would be at 0, 0, and it's been moved 1, 2, 3, 4, 5 places to the left. But remember that if you move to the left, it's going to be written as a plus 5 because this is actually going to be included with x inside a set of parentheses. So what we're going to do is make parentheses and put x, and instead of minus 5, we're going to put plus 5. This is the h, so to speak. And then put that square on the end. It didn't move up or down at all, so there is no number to write on the outside there. Okay, looking at the third one, this is a square root graph. Let me get it straight here. And so the parent function is going to look like this. Okay, square root of x. Well, as we can see, it's been moved down 1, 2, 3. So it's only been moved down. It hasn't been moved left or right. So remember the up and down motions, those are going to get written outside of the square root, just like outside of the parentheses or outside of the absolute value. And so that's going to be the square root of x minus 3. So you can see this is not really a difficult thing. We're going to do a few more. Okay, so now we're getting a little bit more advanced. So the fourth one here is also a quadratic like number 2. So I am going to write the parent function down first. But the first thing I notice is that it is pointing down. And that does come from the value of A. So I know that I need to put a negative sign first. That's going to be the first thing you write after the equals. We also see that the vertex has been moved. It normally goes from 0, 0 and then up, but it has been moved 1, 2, 3, 4 places to the right, and then 1, 2, 3, 4 places up. So because it's been moved to the right, I know there's going to be a number with x inside the parentheses. And remember, left and right, you put the opposite sign. So instead of plus 4, I'm going to put minus 4 and then square it. And then it moved up 4, so I'm going to put plus 4 right there. And there's your answer for number 4. The fifth graph, again, the parent function, that is a cubic. So that's x to the third. And it has been moved. Again, this center point right here should have come from 0, 0. So we're going to move 1, 2, 3, 4, 5 units left and 1, 2 units down. So 5 units left. That means we're going to write it as a plus 5 instead of a minus 5, and it is going to go inside parentheses with the x. So x plus 5 to the third power, and then 2 units down, we write that exactly how it is, minus 2. And there's your equation. Our last one is an absolute value, just like number 1. So I'm going to go ahead and write that. Absolute value of x. I just like to write the parent function down first and then go back and look at what the transformations are. So again, the vertex came from 0, 0. We do a left movement first. So that's going to be 1, 2, and then 1, 2, 3, 4, 5, 6 down. So if I'm moving left 2, that 2 is going to be inside the absolute value with x, but we're going to change it to a plus 2. Remember, anything with x gets changed. And then minus 6. And that's how you write your equations. Now, the assignment that you have, it looks like, let me find it. I think I might have it here. Yeah, here it is, the other side of it. So you're going to basically do the same thing. You're going to do exactly like I did in the video and write the equation. Don't worry about any stretches or compressions. Just go ahead and do like I did with writing the parent function first and then writing the equation with the transformations.